Alright, here's a trigonometric identities problem, and in this problem we were supposed to be able to show that this particular a function can be expressed in this form here, where it's r times the cosine of the difference of two unique angles. Theta will represent the variable, the unknown, and alpha will represent a fixed angle, and that's our objective. So whether or not you know how to approach this problem, one thing's for certain, I can at least figure out what this is using a compound angle identity. So that's where this is written down. So once again, we need to understand that alpha is a constant, so the cosine of alpha is just a fixed ratio, the sine of alpha is a fixed ratio, and r is a fixed number. Well, if they are equal to each other, then 4 cosine of theta, 3 sine theta should be equal to r cosine theta sine alpha, sine theta sine alpha. And what I've done here is drawn out the constants, fixed constants, and the variable part, and another fixed constant and the variable part. And in order for these two to be equal, the 4 must be equal to the r cosine theta, and the 3 must be equal to the r sine alpha. Solving each of those two separate equations, we learn that the cosine of alpha equals 4 over r, the sine of alpha equals 3 over r, can be expressed in a right triangle as shown. Using Pythagorean triples, we know that the radius, or the hypotenuse, has to be 5, and we can figure out alpha by finding the inverse tangent of 3/4, or the inverse sine of 3/5, or the inverse cosine of 4/5. We would end up with the same angle every time. The rest of the problem had to do with the calculus. And the idea here is if we can express the function in the new form, then it would be a lot easier to do the calculus, and especially find the optimal value, the maximum or minimum in this case. So we're trying to find out when the derivative, well, first we need to find out the derivative, and then we need to find out when the derivative is equal to 0. And again, this is an easier equation to solve. And we can find that in order for the sine of anything to be 0, then the angle itself, or the argument, has to equal 0. Well, this is just basic trig. You can pause the screen if you want to copy this and try to think about it more. If you have any questions, let me know. But the point is, I was able to go to Desmos and make sure that within the given domain, 0.644 was indeed the maximum, or it gave us the maximum value for the function. So there you have it. Hope that's helpful.